Good day, doctor and my fellow friends. Today I would like to present the topic of the digital communication. So today our objective will be in two objectives, which will be understanding the concept of analog and digital communication system and modulation techniques. And the other objective will be understanding the impact and benefits of digital communication in society. In analog communication, data is transferred in analog signal in between the transmitter and the receiver. Data is converted into electric form, then passed through the communication channel or transmission medium. In analog communication, it uses a continuous signal which varies in amplitude, phase, or some other property with time in proportion to that of a variable. In digital communication, digital signal is used other than analog signal for communication between the source and the destination. In digital communication, physical transfer of the data occurs in the form of digital bit streams such as 0 and 1 over the point-to-point or point-to-multiple-point transmission medium. In digital communication, the digital transmission data can be broken into packets as discrete message, which is not applicable in analog communication. When connected locally, data can over quickly. However, we must transform digital signal into analog signal in order to enable long-distance communication. This is why we need modulation in communication system. Modulation. What is modulation? Modulation is a device that performs modulation, analog and digital modulation. We have digital modulation, which is aimed to transfer the digital bit stream over an analog bandpass channel. And in daily life, digital modulation are applied in telephone network, radio station to broadcast music over the radio. So we have amplitude modulation. Amplitude modulation is a modulation technique used in electronic communication, most commonly for transmitting messages with a radio carrier wave. Amplitude modulation signal generated by the modulator which modulate the modulating signal and carrier signal. Amplitude modulation is the change in the amplitude of the carrier according to the modulating signal. As you can see from the picture, here is the message signal, means the source. And by using the carrier signal, we can modulate the modulating signal in this envelope form, so that this is called amplitude modulation. And other than amplitude modulation, we have angle modulation. Angle modulation is defined as the process in which either the frequency or the phase of the carrier signal varies with respect to the message signal. There are two types of the angle modulation: frequency modulation and the phase modulation. Frequency modulation is frequency of the carrier wave varies linearly with the message signal in the frequency angle modulation. The phase modulation is the phase of the carrier wave varies linearly with the message signal in phase angle modulation. Next, we will look at radio digital modulation. Radio digital modulation employs a technique similar to the analog modulation in which the modulating signal, digital signal, varies the amplitude, frequency, or phase of the carrier signal. There are four types of the digital modulation techniques, which is amplitude shift keying, ASK, and we have frequency shift keying, FSK, phase shift keying, PSK, and we have a quadrature phase, PSK. Let's look at it one by one. And let's look at the ASK. So ASK is a digital modulation technique in which the amplitude of the carrier wave output of the carrier signal is altered according to the modulating signal input in the digital signal. So you can see that from the picture here, this is the generation of the ASK signal. As you can look at the picture here, when we have input binary in digital, then in here we have the output of the ASK modulator output wave. If it's 0, means there's nothing here, and if it's 1, then you can see there's a wave here. ASK simplification method is on-off key or OK modulation, which the source sends no carrier when the digital signal is 0. And this modulation is commonly used in short-range wireless application and low-frequency RF application. Next, we'll look at the frequency shift key, FSK. FSK is the frequency modulation the technique in which the digital information is transmitted through the discrete frequency change of a carrier signal. The output of a FSK modulation wave is high in frequency for a binary high input, while it is low frequency for a binary low input. The bit 1 is called mark, while the bit 0 is named space. So here is the generation of the FSK, and as you can see here, when we have the binary input is 1, we have a higher frequency in the FSK modulated output wave. If it's 0, means we have less frequency. Next, we'll look at PSK, phase shift key. PSK, also known as BPSK, is a very popular digital modulation scheme. It shifts the carrier sine wave 180 degrees for each change in the binary state. The phase of the carrier is set to 0 degree or 180 degrees depending on the digital signal. PSK technique is used in many kinds as a communication, such as a wireless LAN, biometric, and also RFID and a Bluetooth communication. As you can see, when we have a change from the binary 1 to 0, we have a shift change 180 degrees. And now we were looking at QPSK. QPSK is a form of a phase shift keying in which 2 bits are modulated at once, selecting at one of 4 possible carrier phase shift: 0 degree, 90 degree, 180 degree, and 270 degree. It allows the signal to carry twice as much information as the PSK using the same bandwidth. QPSK is used for satellite transformation of cable modems, video conferencing, cellular phones system, and many more. As you can see from this picture, here is the 0 degree, here is the 180 degree, here is the 90 degree, and here is the 270 degree. Now we'll look at baud rate and bit rate. Baud rate is the unit for the symbol rate or modulation rate in symbol per second. Bit rate refers to the total bits transmitted in 1 unit time. The unit of bits rate are kbps, mbps, gbps, and etc. So from here you can see, here the baud rate is 10 and here the bit rate is 10, because at each 1 second or in one symbol, it will only transmit one bit of the data. But here the bit rate is 20 bps, because in one symbol we have 2 bits of data is transmitted, but the baud rate is still 10. Now let's look at the importance of the digital communication in our society. Nowadays are not possible to avoid digital communication. They come in many forms, such as SMS, web chat, email, and etc. From the telegraph in the 80s until now, the latest smartphone, our communication system is keep on moving forward. But there's pros and cons in our digital communication, such as we have the much more convenient than before. We are doing things quite effective and quick, and we can spreading the knowledge with many kind of platforms such as YouTube. We have data can be shared globally, and there are some cons, which is we are over rely on the social media, which we trust more on our social media, and some of the illegal activities such as scam happening in social media or digital communication, and there's a risk of leaking the personal privacy. So there's a pros and cons in the digital communication. Alright, at the end I would like to summarize what we are talking about today. First, we are talking about the type of the modulation, which we have amplitude modulation, angle modulation, and digital modulation. And we have several types of the digital modulation, which is amplitude shift key, frequency shift key, phase shift key, and quadrature phase shift key. And we also talk about the baud rate and the bit rate. The baud is the total number of the signal units transmitted in 1 second, but the bit is the total bit transmitted in 1 unit time. Thank you for your attention, and we would like to see you next time.